So in the previous video we plotted y equals x squared, and I introduced that as a parabola. So the word that is used to represent that shape is parabola, and we refer to all curves of the form of y equals, when general, ax squared plus bx plus c, these quadratics, so anything that is a quadratic we refer to as a parabola. So y equals x squared we plotted, but if we sketch it, this is essentially what it looked like, something like this. Okay, so this is a parabola, and if I was to, let's say, have y equals x squared take away 4, then this would also be a parabola. This one would actually look like this, where it would be go through -4 on the y-axis. So you can see that this and this, these two curves, have precisely the same shape. It's just that what's happened is that I've picked this one up and I've moved it down 4 units to get that one. So all quadratics of the form of y equals x squared plus something x plus something, they are all exactly the same shape. They've just been moved around somewhere else. So it's the original one picked up and moved to some other location. So they're all the same shape. Now, if we just take a look at these two, just to kind of start this off, is there any property of the parabola that we should be aware of from the outset? Well, the y equals x squared curve and the y equals x squared take away 4 curve, for example, they both kind of show this off quite well, because as you can see, this part of the curve is the same as this part of the curve, but the mirror image. So the y-axis here acts as a mirror, and it does here as well. But if I pick up and move the curve somewhere else, the y-axis may no longer be the mirror line. So I'll write down what the equation is. So let's say this one. Okay, so don't worry about thinking, oh goodness, what does that look like? But I'll tell you, just to kind of show you where this is going. So here is y equals x take away 2 squared. Goes through 2 on the x-axis. But you can see that it's not symmetric about the y-axis. The y-axis is no longer a line of symmetry. But the line of symmetry is still there. So this time, the line of symmetry is here. So all parabolas have this line of symmetry. Okay, they all have a line of symmetry, all have a mirror line, and that actually makes it easier to plot them, because if you know, for example, these points here, then you know that these points here must be the case. Okay, they must have those mirror image pairs, which is really useful to know and to help you along with plotting. So these parabolas don't always have to be that way up. So if I was to put a minus sign in front, so let's say we had y equals minus x squared, then this curve looks like this. Now you can see that it still has the y-axis as a mirror line, okay? But placing that minus sign there, what it's done is it has reflected the graph down in the x-axis, and you get this shape instead. So this is still a parabola, Okay, so just because it's up, not up the other way, we still refer to it as a parabola. It's, as I said, it's just up the other way. And then, of course, you can pick this up and move it to wherever you want. Now, what if, instead of putting a minus sign in front, we put a 2 in front? What does that do? Well, is it still a parabola? Y equals 2x squared will look like this. Now you might be going, well, that doesn't look too dissimilar from my first sketch of y equals x squared. Are they the same? No, they're not the same. They both have the property of having the y-axis as a line of symmetry. They are both parabolas, so this is still a parabola, okay, because it's a quadratic curve. All quadratic curves are parabolas. However, what that 2 has done is that it's actually stretched the graph out in this direction. Now, though, you could also argue that it's squashed it inwards, but for the purpose of this, I'll just say that it has been stretched outwards. So if I was to superimpose the original graph on, y equals x squared would look something like this. Okay, so it's a little bit, it'll be shallower. And this one, our y equals 2x squared, is a result of stretching y equals x squared, like so. Okay, so stretching it in this direction. And yes, it is still a parabola. So the key to this is, you know, my expectation at this stage is that you won't know if I write down an equation what it's going to look like. Okay, that's not the expectation at this stage at all. What you need to know is that if I was to write down y equals 3x squared take away 2x plus 5, for example, you would understand that that is firstly a quadratic. Okay, so it is a quadratic. And because it's a quadratic, its shape will be a parabola. Because it's a positive 3 at the front, its shape will be something like this. It will have that U shape, okay, and it will be that way up. If I was to write down instead y equals minus 5x squared plus 9x take away 3, this is a quadratic. Because it's a quadratic, its shape will be a parabola. But because of that extra minus sign there, that means that the curve will be this way up instead. Okay, because you'll be having a negative multiplying the x squared term. So at this stage, what we're looking for is, I know that that is a quadratic, so it's a parabola, because it's got the x squared term, and that's the leading x term. So that's the most powerful one, if you like. And because it's a positive at the front of the x squared, I know it's going to be that shape. So if I was asked to plot one of these, I know roughly what it's going to look like. I know it's going to look like this, or it's going to look like this if it's something like this. And I know that both of these have that line of symmetry